Chapter 10 will continue with motors and motor components, and you'll see how this information will kind of branch into your project. You will look at motors and see how they work, and we will work a lot with motors. So we want to know all the components and what goes in there. Here is some information that you might find useful. I'm not going to ask you this in the quiz, but you might find this useful later. So if you have a capacitor that you didn't know, there's no microfarads on it, and you want to match the microfarad and see what is the replacement. This is what you do. So you charge a capacitor, you put a clip on, I'll get a clip on it, charge it for like 20 seconds. Then discharge it and measure the amperage draw. Or while you're charging it, measure the amperage draw. So once you get the amperage draw, you multiply that by 2,650 and you divide by the voltage applied, and that should give you the microfarads within reason. That's just a trick that you can use if you went to an old equipment and you did not know what kind of capacitor is that. And probably you run into those. They used to make those compressors really rugged, so they last a long time. I've seen a compressor that's been running for 30 years. 30 years. Especially compressors that do not stop. If you have any rotating equipment that does not stop, will last longer than the one that stops and go all the time. Because every time you stop, it causes friction. Once it's running, it's completely having the time of its life. Nothing touching, just like imbalance in the zone. It's kind of like that, huh? It's kind of the jet engines. Once it's up there, 10,000 feet, it's cool, it's nice, it's balanced. That's what it's designed to do. Every time it takes off and lands, that's when you have issues. But other than that, once it's balanced, it's balanced. So the same things. We had a pump actually in the plant that was a fire pump that was running for I think 20 years, and we kept it running for 20 years, non-stop. And one time we had a shutdown, like to do maintenance, so we had to shut down that system, and that's when it broke. If it's running, just let it go. Don't stop. We usually don't like shutdowns. Every plant has a major shutdown every 5 years. Up to the semi shutdown 5 years. 10 years you have a major shutdown for every refinery and power plant. And actually the shutdown causes a lot of problems because of that. Things stop, then they don't work again. For replacement, we talked about that. For starting capacity 120 plus or minus within the range, and for running capacity 10%. We said that before. Write that down. You might need it one day. And again, do not sell your book. It has a lot of information that you need in the future. And this book you will use for 3 or 4 courses. Okay? We did that again, the quiz, the RPM, how do you calculate the RPM of a motor. And here's an example. The most common ones are 2 poles, 3 poles, and 4 poles. I didn't see something that deviates much from that. So, after reading this chapter and going through it, we'll talk about motors usually that are used in compressors and what kind of starting configuration do we have or starting layout, and what kind of starting relay do we have. We have starting relays, starting capacitor. All these are means to shut down the start winding. So when we took the motor apart, what stopped the start of winding, if you remember?
Which motor?
It's a centrifugal switch. You turn it on, within 2 seconds you hear a click. That cut off the winding. Maybe we should do an experiment when we disengage the switch and see what happens. So we'll just keep spinning faster and faster until eventually it will overheat and it will pop. So this is a way to cut out the start capacity. There's something called a potential relay, which does the same thing. You have a start of winding, but centrifugal switch are not installed on compressors. That's why we use something from the outside, either a capacitor circuit or a potential relay. So we'll talk about potential relays. We'll talk about new replacements for potential relays. How do we troubleshoot the install motor, starting relays on a hermetic compressor motor? It's from the outside again. How do you troubleshoot the capacitor? How do you troubleshoot the starting relays? Type of motor drive used in the industry. What do they mean by motor drive? But there's 2 types for us.
Oh.
Direct drive, where the motor
Shaft.
shaft, or you can have a belt. The purpose of the belt is you can locate the motor far away from the fan or pulley, and you also can increase the torque by having bigger or smaller pulley. Same thing with your motor. Why do you have gear? You have the first gear, high torque, low speed. Second gear, lower torque, higher speed, and finally the fifth or sixth gear is almost as the same RPM as the motor. Very, very low. So in the past they didn't put a lot of gear in the car. They had only three or four. That was it. Then they, as the requirements for, I always wondered about that when I was young. Why can't we just like have a more? So in the highway you don't have to have 2,000 RPM.
Now they go up to 10.
Yeah, Lexus.
Fords now too.
10?
10,000 RPM?
No,
No.
10 gear.
10 gears.
Yeah.
10 speeds.
The constant, the one, the CVC,
CVT.
did not take it much in big cars. It was good in small cars, they didn't put it.
I know they had them in the Muranos.
Yeah.
They need some
They
Muranos.
also have them in the Civics. It's kind of a
Alright.
pain. But I know the Lexus 430, they have 8 automatic gears, and some of the BMWs have 10. So the more you, the better. The goal is in the highway you'll be at 1,000 RPM because the car's already moving, and you have a lot of torque, and you don't have a lot of switching between the gear. So that's an idea, and that's why we have different kind of drive. And sometimes one motor can run 2 or 3 things. You can do that as well. Same thing with your motor. Back in the day, 20 years ago, the 20 years ago, the car had an engine, and the engine would have a belt. That belt goes to the AC. Another belt goes to the water pump. Another belt goes to the alternator. So they have at least like 3 or 5 belts. They came up with one belt that goes to many pulleys, so to run other things. So the drive is distribute the work. So you have, instead of having 3 or 4 motors, you have one motor. Okay, how do we calculate the variable V-belt drive applications from one to another? It's a very simple arithmetic. It's not that complicated. It has to do with torque. Remember when I did that schematic and I said that this is our center of operation, and I have a lever here and force. The amount of torque applied here equals force times distance. That's being said, we also have to do with the RPM. So if I have a small pulley and a big one connected to a belt, there's a relationship between the RPM and the torque. RPM, torque, and the distance between here and here. So the radius makes a big difference, and we'll change the torque and the RPM, and we'll see that in 2 examples. V-belt applications and the proper tension and alignment. Make things simple. Do not complicate things. I'm trying to very simplify these applications. What's a V-belt? It's a small belt that you have between your engine and your alternator. Why is it called a V-belt? Because yeah, because the V is kind of like this. Or sometimes it goes in a groove, so it will hold. And the purpose of doing it this way is to have more friction, so it will hold. And now they have the big ones, the smaller of these, wider. Yeah, those are the new ones. And some of them actually they go back and forth, so you use both sides for that kind of belt. So the belt kind of transforms energy from one pulley to another, and the size of the belt and tension makes a difference. What, as a general rule, how do you measure the tension of your car? Remember, sometimes in the summertime when you turn on your car, it squeaks. Why?
In the summer? Oh, humidity?
Summer in the humidity, and also the heat, it can expand the belt. So it's a little bit too loose. In the winter it's too tight, it will squeak, but what it's squeaking is not the belt fully.
Sometimes the brakes that need to change when you brake.
No, but that has nothing to do with the belt. So the belt need to be, again, the right tension. And if you go again to a mechanic shop, they have a tensioner, belt tensioner. But in general, what do? You push with your thumb while the engine is off. You turn the engine off with the motor and just push a little, it should be not more than an inch. It should be some kind of leeway, but not a lot. If it's very loose, you know it's going to squeak and eventually fly off. Again, never test any of those motors while they're running. Some of them have torque, turn it off, turn it by hand before you test it. Okay, so most of the motors we have in ACs are single phase hermetic motors. They require external starting components, and they keep it always external because they do go bad, and it's easier for us to fix it. If you look at the hermetic compressor behind you over there, it's sealed, it's tested, it does not allow any refrigerant out in case something breaks or it leaks. So that being said, we need to have different kind of starting wiring, dropout equipment. Either it's going to be a relay, we can use a capacitor with a circuit, or we can use, now they have some kind of solid state relay. So let's try to identify them and find the replacement. Sealed area, starting relay are used to, there's something called a current relay, potential relay, and solid state. So current relay, what does it do? So we said whenever we run current through a wire, what happens to it? Two things. It gets hot.
Creates magnetic field.
Magnetic field. So current relay basically has a coil that touches the wire going to the starter winding, and once you run too much current, it will drop out completely, and you have to restart the system. Potential relay, that's something similar, but it disengages a switch based on magnetism. Solid state, it's made out of chemical. Once you run current through it, it will change its resistance and suddenly cut off the winding. So current, potential, solid state. You don't have to remember all these types because they do change a lot, but it's important to know what is it when you go and try to replace that. We'll also talk about bearings. What do? So first of all, hermetic compressors. Second, what kind of startup apparatus do we have? Third is bearing. We saw from the motor, what does bearing do? They carry the load of the shaft. So this is the shaft, has the winding in it. You will find the bearing here. All the weight of the shaft relies on the bearing. The stator can be as heavy as possible, but it's not loading on the shaft. It's loading on the whatever it's installed. So the bearings carry the shaft, and they are responsible for ensuring that the rotation is very smooth. What kind of bearings do we have? What do we see from the lab? We have many types of bearings. One of them is called sleeve bearing, which is metal, touching metal with a layer of oil between them. And it's very smooth, and again, as I said, as soon as the shaft starts rotating, the weight is gone and you only have some friction. There's also, this is called sleeve bearing or journal bearing, which is metal touching metal. There's also ball bearing that you find in your skateboard, on bicycles, in your car. These are ball bearings. They look, basically what they're doing, they're trying to reduce the friction. Two wheels and small little spheres inside, kept apart by some kind of ring, filled with oil and pressed. Once the seal is gone, the oil will come out. Eventually it will hit one of the spheres and it will just start making a noise. Probably have For small cars, you'll have bearings. What about for trucks? What do they have?
Grease.
Huh? Yeah, they have sleeve bearings. Because the weight will crush those balls in a second. So you have sleeve, which is basically goes shaft inside the shaft, and inside here just two soft metals, and oil, and that's a sleeve bearing. There's also another application called roller bearings, where instead of spheres and balls, you have rolls. Which gives you more surface area and more ability to withstand the weight. Some advanced motors, they have magnetic bearing. It's the new thing now. So you energize the bearing first.
Is it frictionless?
Huh?
Is it-
Frictionless, yeah.
Yeah.
You turn it on first, it will lift magnetically the shaft, and then it will spin, so it's touching nothing. So it's pretty awesome for some motors. It's an advanced way to do it. For some heavy turbines, we used to do something called oil bearing, where actually we have an oil pump that goes and pumps oil. Let's say this is the bearing. So it will pump oil at high pressure to lift the shaft, then you start it up. So again, that's a whole field of engineering and business, and there's actually 3 bearing companies in the Netherlands that they export things internationally. Yeah.
So, the starting relays, the current and potential, the difference between is that the current detects a change in current.
Yeah.
Amperage, and the potential detects a change in voltage.
No, it's still in amperage, but it reacts using a magnet.
Both
Like it will
potential
pull
and
something out.
current.
Huh?
So both current and uses.
They both do current, but they just react differently.
Oh, right.
Yeah.
And they both use magnetism,
Yeah.
so the styles.
Except for this one. This one is chemical.
So it's chemicals
Yeah.
that heat up?
Huh?
Do they?
They change resistance with over temperature. Yeah. So ball sleeve bearings. We have starting relays for single phase motor. Again, we always have to have a mean to drop the voltage once we start, otherwise we'll keep running. The exception is the permanent split capacitor motors. They don't need any mean to start the motor because they are very small and they have their own winding inside. And we use a centrifugal switch on the motor, which what we have inside the rotor. So that's the most single phase. They need a way to start the motor, except for permanent split capacitor motors, or ones with shaded pole and centrifugal switch. The one we have here. This one does not have a capacitor. It does have a startup winding, and it drops by a centrifugal switch. Okay. So what did we get so far? There are means to drop out the startup winding, either a centrifugal switch, relay switch, solid state switch, current relay. There are different kind of bearings, ball bearing, sleeve bearing, journal bearing. They're very important to prevent the smooth rotation. And there are 2 kind of drives, belt drive and direct drive. What is direct drive? This is connected to the pump directly at the same speed. Okay, that's it for today.